Academic foundation, and the apparatus you're seeing in front is okay. They are used for showing how a leaf contains starch, and the apparatus printed below are the test tube rack, the boiling tube, the Bunsen burner, a dot stand, the wire gauze, the stop clock in the white tile, and this is test tube holder plus the thermometer. And now the use of this apparatus I've mentioned, the stop clock is used for measuring time, and test tube holder is used for holding test tubes, and of course used in like experiments. After carrying out the experiments, you put your outcome on this one for easy viewing. This thermometer is used for measuring temperature. So boiling tube is used for boiling solutions. Test tube rack is used for holding test tubes, and of course can also hold the boiling tubes. And here we have the distilled water, the iodine solution, the ethanol, and our potted plant. And this one as well, we potted this plant is because it has been observing light, has been heated for over 12 hours, so we don't just carry it from there. We got it when it is potted to prevent issues of drying up or even desiccation. Simple terms. So our Bunsen burner here is used for releasing out flames, also when you're using gas, for the issue of just heating up our solutions. The dot stand is used for holding the wire gauze for easy heat. The space allows the fire to reach the wire gauze, This is just for holding. In case you're using a beaker, just put it on top and it cannot go through it. So, in brief, these are the apparatus we're going to use. And let me allow my colleague I'm working with to also introduce himself, as he's going to take us through the rest of the processes in testing.
Hello, dear viewers. My name is NCDC, a proud student of the A.I.A Academic Foundation. As our previous speaker has said, the experiment of today is testing of starch in a leaf. The first thing you need to do is to detach the leaf from the potted plant. First, you need to boil the distilled water at 100 degrees Celsius.
Wait.
I think it's backwards.
Backwards like this.
Okay, now as you can see, we are boiling the distilled water. So you must boil the distilled water up to 100 degrees Celsius. So you keep checking the temperature until the water boils at 100 degrees Celsius. That's when you can do the other process of inserting this with the ethanol. So we're going to keep checking and testing it until it has fully boiled. Okay, as you can see, we are waiting for this water to boil, and the water should boil at 100 degrees Celsius. So we're going to keep testing until it boils at 100 degrees Celsius. As you can see, it is now at 38 degrees Celsius, and we're going to keep testing until it reaches 100 degrees Celsius. That's around here. So as we wait for the water to boil, colleague of mine will explain the rest of the process as we wait.
As we wait, let us be detaching the leaf from the potted plant. When the water reaches at 100 degrees Celsius, we will place the leaf. Now the question is, why are we placing the leaf in the boiling water? This is just to kill these plant cells without damaging them. We can go back to checking on our water which is boiling.
So as you can see, it's now on 44 degrees Celsius, and which is supposed to wait up to 100 degrees Celsius. So we're going to wait for some more time.
As we wait for the water to boil, we can talk about our potted plant. The reason why this plant is placed in this pot is only to allow it to get the optimal water it needs, and also to put it in the right amount of light whereby it can receive it from the sun. As we said, the aim of this experiment is about testing whether a leaf has starch in it. The way starch is formed in plants is through photosynthesis. These plants need light, water, carbon dioxide, and mineral salts to make their own food. That is why we have left this plant in a pot, so that we can allow it to get enough water it needs to absorb in order to enable it to make starch. Also to place it in the right place which has the minimum amount of light it needs to carry out photosynthesis. As you can see, our leaf is green. This is an indicator it has chlorophyll in it. This is the same chlorophyll which traps sunlight to enable it to carry out photosynthesis. Photosynthesis takes place in the palisade cells of a leaf. These palisade cells contain chloroplasts. The chloroplasts contain chlorophyll, that green pigment you see outside of a leaf. During this process of photosynthesis, water, carbon dioxide, and light are mixed together to form starch and oxygen. Meanwhile, we can give them back to our water, which is boiling.
So on 65 degrees Celsius, and it's now the water is at 65 degrees Celsius, and the current temperature is increasing. It's now on 600 degrees Celsius, which that is its boiling point. And of which the leaf is going to be boiled for 5 minutes, and we're going to measure the time using a stop clock. So as soon as 5 minutes, it will be ready to be removed from there.
You can put the camera on ethanol. As you can see, the ethanol is colorless. The ethanol is identical, the same color. It is very colorless, like the water. Some of the rules and regulations in the laboratory state not all things found in the laboratory, not all liquids found in the laboratory, not all colorless liquids found in the laboratory are water. As you can see, if you're to leave this beaker filled with ethanol unlabeled, a person cannot easily tell the difference between it and water.
Okay. The stop clock is measuring the time, and so far it's 2 minutes. So it's supposed to wait for 5 minutes for the leaf tissues to be broken, so that you can easily access the starch that is inside. So until it's 5 minutes, that's when we shall be able to remove the leaf from there. So now our 5 minutes have reached. As you can see, this one here demonstrates the minutes, and this one counts the seconds. So it's showing that our 5 minutes have reached. So the leaf will be removed this time.
It is done in not 5 minutes. So you try to stay here. So you need to spray.
After you've removed the leaf from the boiling water, then you can place the ethanol through a boiling tube.
No. Yes. I do. Yes, I'm going to measure.
The ethanol is enough. So now, the ethanol is placed in the hot boiling water, enable it to also boil. The reason why we are not placing the ethanol to direct heat is only because it burns out when placed to direct heat. As you can see, the ethanol is already reacting faster. The temperature, it has already been put. It is already boiled. After the ethanol is already boiled, we place the leaf. The reason why we're placing the leaf in ethanol is only to decolorize the leaf. can see, the leaf is already decolorizing.
So as a reminder, we'll also time the leaf for 5 minutes, and so far 1 minute has passed. So wait for it 5 minutes. So far 2 minutes have elapsed, and we're still waiting for 5 minutes, so 3 minutes are remaining. Then we shall remove the leaf out after 5 minutes.
You may not show them the clock, but it's decolorized wood.
Our 5 minutes have elapsed, and the leaf is going to be removed from the boiling tube.
Show them the color, show them the color.
Before the leaf was placed in ethanol, it was green. As you can see, the ethanol has decolorized the leaf. You can compare these two colors. One is green, another is colorless.
The ethanol is green due to the green pigment, that is the chlorophyll from the palisade cells, and of course it also contains the starch, which is the leaf.
Now you can compare between these two leaves. One is green, another is white. The green pigment has already been absorbed by the ethanol.
First two activities we performed made the leaf to be brittle and the first very fragile. So in order to deal with it, we boil warm water, which we might boil up to 40 degrees Celsius, and we have this space. We are now almost clocking to 39 degrees Celsius. Okay, as you can see now, it has reached 40 degrees Celsius. So we're going to insert the leaf into it.
You can see the leaf is already soft enough to be removed from there. As you can see, the water which has been heated up.
So
now you can compare the two leaves. This is the fresh leaf, while this one is the leaf which has been placed in the two solutions. Notice the difference. The leaves have been placed on a white tile for them to easily be viewed, for other colors to easily be seen. Now,
The observation of color changes.
the reason why they're using a white tile is only because it easily shows, it easily makes the other colors visible. Like you can already see, green is more visible here. We add iodine solution. We add 4 to 5 drops.
The entire leaf. Give it time. No, it's fine. Why do you get a combo? It's not allowed. As you can see,
the color of the leaf is changing. The leaf is becoming darker.
The color is black, not dark.
The leaf has now become black. You can already see. The leaf is already black. This shows that there is presence of starch in this leaf. Now you can compare the iodine that has been placed on this leaf, which has been absorbed by the leaf. It's slowly reacting with the starch granules, making the leaf color to become black. As you can see here, this leaf has starch, that's why its color has changed to black. If the leaf did not contain starch, its color would have been yellow or orange. As you can see, the color of the iodine which has been dropped on this white tile.
What is the next game? Been recording.